This is for Year 12 methods. It comes out of Chapter 10, 10C, about stationary points. It's question number 7. So the curve with this equation has this stationary point. Okay, stationary point at 2, 7. So I know two pieces of information about this. I know that when x equals 2, then dy dx equals 0 because it's a stationary point. And also know that when x equals 2, y equals 7. So it's going to be my simultaneous equations that I'm going to use to solve for a and b. Now what does it look like on calculator? So I've defined f of x. So my simultaneous equations will be, I know that f of 2 equals 7. And I also know that the derivative equals 0. So if I do second function, if I select that and do the derivative of x, and if I make it equal to 0, math 3 given x equals 2. Now I don't want to put the 2 in first because I want to take the derivative. Then once I've taken the derivative, substitute that in and solve that for a and b. So a equals 2 and b equals 9. Now what was that? That was simultaneous equations where f of 2 equaled 7 and f dash of 2 equals 0. Solve for a and b. And then find the coordinates of the other stationary point. So if I then take this and I do given a equals 2, also given b equals 9, that's going to be my f of x. Take the derivative and set it equal to 0. So take that. Math 2 derivative with respect to x equals 0 and solve for x. I know there's one answer. That answer is x equals 2 and the other one is -1. So if I take f of x and I make x equal to -1, and I know that, where's my a and my b? Given those, copy, answer, paste, therefore -5. So the other coordinate is -1, -5, and a equals. Now the rest of this I'm going to do it as if I didn't have a calculator. So y equals ax plus b times 2x minus 1 to the -1. I know that y of 2 equals 7, therefore 7 equals 2a plus b times 4 minus 1 to the -1, or 7 equals 2a plus b on 3, which is 21 equals 6a plus b. That's equation number 1. I need to take the derivative. So dy dx will equal a minus b, because the -1 will come down, 2x minus 1 to the -2, times the derivative of the inside, which is 2. So a minus 2b on 2x minus 1 squared. And I know that that equals 0 when x equals 2. So a minus 2b on top of 9, because 4 minus 1 is 3, 3 squared. Multiply by 9. 0 equals 9a minus 2b. And this is 42 equals 12a plus 2b is equation 3. That's equation 2. I'm going to add these two equations together. 0 equals 9a minus 2b, and 42 equals 12a plus 2b. 42 equals 21a, therefore a equals 2. And I can sub that in here, that 2b equals 9a, 2b equals 18, b equals 9. So a equals 2 and b equals 9. The same answers that I got over there on calculator. And the second one was find the stationary points. So I know that dydx equals a, which is 2 minus 18 on top of 2x minus 1 squared. If I set that equal to 0, 2 minus 18 on 2x minus 1 squared is going to be, move the 18 over here, 2x minus 1 squared equals 2. Move this there and move the 2 down. 18 on 2 equals 2x minus 1 squared. 9 equals 2x minus 1 squared. Take the square root of both sides. 2x minus 1 equals plus or minus 3. Therefore, 2x equals plus or minus 3 plus 1. And for x equals plus or minus 3 plus 1 all on 2. So that's either going to be, x equals minus 3 plus 1 on 2 or 3 plus 1 on 2, which is minus 2 on 2 or 4 on 2, which is minus 1 or 2. Now I knew that one of them was 2 because it was 2 and 7. I need to find the other one, and the other one will be when x equals negative 1. If I come back here to the original, where's my expression? I'm going to have y of negative 1 will equal negative a plus b times negative 1. That's negative, that's minus over negative 3. So on negative 3 and equals a. So minus 2 plus 9 on negative 3 minus 2 minus 3 equals minus 5. Therefore, this other stationary point is at negative 1 and negative 5. So the first part is how to do it on calculator. The second part is how to do it by hand.